Hello everyone, my name is Jingjing Pan. Welcome to my CS5610 Web Development Midterm presentation. Here is what we will cover today. First, we will look at the big picture and concept map of the full web stack. Secondly, we will do a concept overview discussing how HTML, CSS, JavaScript, Node, Express, and MongoDB fit together. Then we'll take a deep dive into Express and MongoDB, looking closely at rules, middleware schemas, CRUD in depth. Finally, I'll do a live coding demo where we build a mini REST API from scratch. So first, let's look at the big picture. So when first wrapping our hands around the full stack flow, our slides uses a great analogy, the registrar's office. So how does a web request really work? Think of it like getting your transcript. In this model, the front end is the student who will ask for like official transcript. I need my official transcript, please. And then the Express backend is a busy man who are managing incoming request. The mid will act as a security or front desk, checking student ID like that. So imagine I'm a middleware. I will ask, do you have your student ID? Check the auth before anything else. And if you passed, the express router represents the specific service window. There are many service windows. For example, Windows 1 deal with admission staff. Windows 2 deal with transcript. So each root handles only one thing. And Mongoose is the standardized form that enforces the required fields. For example, here the student ID and name are required. So no scrapped paper accepted. We enforced a schema. And MongoDB is the security place where records are permanently stored there. So this is an analogy. And taking that analogy into technical realm, this is what the full stack flow looks like in action. So when a user taps URL or click button on the browser will use HTML, CSS, and JavaScript to render the UI, handle events, send fetch requests like that. So the HTTP request hits our Node.js and Express the backend. The Express router directs the request. For example, here get API to do's, passing it through our middleware. And finally, it requires the MongoDB connection using Mongoose, retrieves the JSON documents, and sends a JSON back to the front end, where JavaScript will update the DOM for the users. The users can get a response from the server. So this is the full stack flow. And now let's break down the actual technology that make up this stack. First, we will look at the front end layer, HTML. It defines the structure and content of a page using nested tags. So here you can say the nested tags like HTML, head, body, like that. CSS and bootstraps, what are they? So CSS layers the HTML, where bootstrap provides a responsive like grid system and pre-built components. For example, When scanning a grid of property cards for an Airbnb listing page in our lecture, Bootstrap's Flexbox and grid classes save us hours of manual scanning. Without it, we have to manually style each HTML. It's quite time consuming, right? So with Bootstrap, we can save time. Then let's say JavaScript. So this is what makes the page come alive. It handles DOM manipulation and assume or fetch API to communicate with the server. We've moved away from the old callback function to modern assume or await syntax for cleaner code. You can see here. It's really, really convenient. And then let's look at the backend layer. Node.js, what is it? This is a JavaScript runtime that runs outside the browser. Powered by Chrome's V8 engine, it uses an event-driven and non-blocking IO model, right? And what is Express? It is built on top of Node. Express is a minimal, unopinionated web framework. It handles routing, middleware, and HTML requests. But here, I have to mention two words of JavaScript. It's really important to know that JavaScript runs in both the browser for the front end and on the server for the back end. But they are different environments. The browser uses the window and document objects. Node.js uses the process object and has access to the file system through FS, but does not have a DOM. Next, let's go to the database layer. So we have learned the MongoDB. MongoDB, this is this is a NoSQL document store database. Instead of tables and rows, data is stored as JSON-like BSON documents within collections. And what is a Mongoose ODM? So this layer adds schema validation on top of MongoDB in our Node.js applications. It maps our CRUD operations, such as create, read, update, delete, to database actions like insert one, find, update one, and delete one. So you can see the code here, update one, delete one, like that. So it's really, really convenient, efficient. And for our next part, deep dive, I want to focus on the Express middleware pipeline. And under this is crucial because it will tell how every single request is inspected, transformed, and resolved layer by layer. So let's trace the exactly life cycle of a request. The first step is about the trigger. The browser sends a fetch post request to API tasks. When a user clicks Add Task on the browser, and then the router, like the Express router, catches this and matches the route using API app.post API task handler, right? And then we will build the request. This is the pipeline. So this is where the magic happens. Each middleware adds to or validates the request object before the root handler ever sees it. So first, the row request comes in. The body is undefined. It's just a row base. And next, express.json function this one will parse the body into a readable JSON object like title by milk. Then it might hit auth mid-will function. This checks the user's token, confirms their identity, and attaches a user object to the request. And finally, the validated request reaches the root handler, the controller. The handler uses the data to call a mongoose method like task create, right? So it will write this JSON document into the collection MongoDB, and then responds to the client with if with 201 created, if it is created successfully. So this is a for request life cycle. Now let's look at what this looks like in actual code. On this slide, we have our root task, task.javascript file. Notice how we use express router at the top. This is crucial because a router separates our concerns by resources. Instead of dumping every single route into one massive server file, we put all task-related routes here. And then we look at the rules themselves. There are three key patterns I want to highlight. The first pattern is assume and await. Assume or await. So inside the get and post route, we use assume and await. This handles our database operations clearly without getting stuck in callback here. The second pattern I wanted to mention is the error handling. So you can see in the post route, we wrap our database core in a try catch block. If the database fails to create the task, it will fails to the catch block, right? And sends a meaningful 400 error back to the client instead of crashing the server. So this is safer. And the last pattern I want to mention is the URL parameters. In the delete route, we use like this one, /id in the path. Express automatically grabs that value and attach it to the request object as a request parameters ID. So Mongoose knows exactly which task to delete. Next, we will talk about how request gets built layer by layer. Each middleware adds to or validates the request before the root handler ever sees it. We can look at the four stage. Stage 1, the raw request. When the HTTP request first hits the server, Express sees the method, the URL, the headers, right? But the body, you can see here, the body is undefined because it is still just a raw base. Then the second stage, the stage 2, body passed. The request passes through our first middleware, express.json. This function passes those raw bits into a readable JavaScript object. Now you can see the request.body magically contains the title by milk and a boolean value false for done. All right, you can see this. Next, let's go to the stage 3, user attached. So it hits our custom auth middleware. function. This function checks the authentication token, confirms the user's identity, and literally attaches a brand new user object right onto the request. So you can see here, the request has both the body data and the user data, like ID and role. And then go to the last stage, stage 4, like the root handler. By the time the request finally reaches our root post handler, it is fully loaded object. We can safely grab the task title from the body.title and the owner's ID from the user.id to create our database entry. I have to mention, I think it's very important for us to know the next function. The glow holding this entire sequence together is the next function. Each layer must call next to hand the request to the next step. If any meet will fails, for example, if the auth, like this one, auth token is bad, it doesn't call next, and the pipeline stops dead right there. It just stuck here. Yeah, this is for part 3. And then for the final part of my presentation, I'm going to demonstrate how efficiently these tools work together by actually building a mini task API from scratch. So here are some steps. The first step is the initialization, right? And the second step, we will need to create a JavaScript file to connect to the MongoDB. And in this file, we have to create task model with the Mongoose schema. And then we will have 2 routes, like get tasks and post task routes. And later, I will test with Postman. So let's go to the live coding demo. Okay, here I have created a folder, and in this folder, I created a file, empty file, server.js. So follow the step here. First one is initialization. I will initialize my Node.js project and install my dependencies, right? So here, let me clear first. So here, let me initialize it. I will run this command. Okay, you can see here, this gets our environment ready. And then the second step creates a server.js and connect to MongoDB and set up the express. Let's write it into the server.js file. The first step, like set up the express. So I will have a variable like express, required express, and the mongoose, required mongoose, right? And I use the express here. And I will have a middleware here, like app, use express. Why I use this one here? I think this one is really important because it can convert the raw data into request body, like I said before. And next thing, it will be connect to the local, connect to the local MongoDB database. Let me write it here. Yeah. I will write the local MongoDB database like this one. We connect to this. If successful, we will print print this one, like MongoDB connected. If not, we catch the error and print the error. And next, let's create task model with the Mongoose schema. Mongoose schema, right? Schema and model. Let's have that. So for the Mongoose schema for our task API, I have already found this one. So this is a schema. We will have a title, done, and create at. So the title is the title of the task. The done is the value for our task status, and the time is when we create it. Once we have this, we have a task model. So task, well, Mongoose model task schema. And then I will write the rules here. Well, I have two rules, get and post. Get, post here. So first, I will write a get task, fetch all items. Add here. Sim. We will try. We will try like find. Yes, we will like try. Task will find, and if it's successful, it will respond the JSON. If not, we'll print the arrow here. And then for the post, have the post here. Let's try. We will have a task like await task dot create a body. And if it's successful, the request dot status will respond as a 201. If not, we'll have an error, right? So this is these are two rules, get and post. And finally, let's spin up the server. So as a listener, right next this one. Okay, this is a server API. Let's run it. Yeah, we can see the server running on port 3000 and MongoDB connected successfully. Then let's go to the Postman to test it, right? So I will have a post and a get request. So here I'm going to send a post request to localhost 3000 tasks path. In the body, I'm only going to send one pieces of data like title, midterm preparation. Let's send it. Okay, you can see we get a 201 created status back with our new BASIN document. Notice how successfully the Mongoose schema did this job. Even though I just wrote a title here, right? The database automatically fill in done. And the create timestamps. And you can also see two actual values here, ID and V, and /V. And the ID is a unique 24 characters primary key automatically generated by MongoDB. So we can look at this exact task up later. And the /V is a version key added by Mongoose behind the scenes to safely manage the concrete updates. So this is for the post. And for the get, we get all the tasks. So let's send it. Okay, you can see the previous one is I tested before, and this one is I just test last time, right? So midterm preparation. We get it successfully. You can check midterm preparation here. So, and now we can see just like this, we have a fully functionally database connected API. This is my live coding. This is the whole content for my midterm presentation. Thank you for listening. If you have any questions, feel free to contact me. Thank you. Bye.